So next we're going to talk about something referred to as passive transport. Okay, well, let's dissect that. So passive, the word passive means that it's sort of just happening, right? Nothing's making it happen, and we'll talk a little bit more about that as we move through the note. Transport, well, if we're referring to the cell membrane, then transport probably refers to anything that's being moved into or out of the cell, right? So let's think about it. Well, what kind of things might be moving in and out of the cell? Well, we have, waste such as CO2 and maybe some other wastes, metabolic wastes. Oxygen might be moving in to the cell, and we might also have some nutrients such as, say, glucose, for instance, that will have to pass in and out of the cell. And the reason for that is because the cells have to maintain a consistent environment, and so that means that materials need to move in and out. So, well, what is passive transport? That's when we move materials across that cell membrane, but without using cell energy, and that is the key. So what I want to talk to you today about are the different types of passive transport that can occur across the cell membrane. So the first you're very familiar with, I hope, which is diffusion, the concept of diffusion, right? So I usually start to explain this by having you envision that somebody decides to spray perfume in one corner of a room. And so at the beginning, the moment that you squirt that perfume, you spray that perfume, all of the perfume molecules are going to kind of be in that one edge of the room. But, all matter in the universe tends towards disorder. Those molecules are going to bounce off of each other, and they're going to want to move away from each other. And slowly over time, we see that the molecules end up spreading out very evenly in their given amount of space, right? So they move from what we call a high concentration gradient, okay, to a low concentration. So we say that they're moving with the concentration gradient, okay? Anytime atoms or molecules are moving from an area of high concentration to low, that's the way that they will naturally want to move. So we say they're moving with the concentration gradient as opposed to against it. Okay, that's a tricky one. So if you have any questions tomorrow, ask me and I will give you maybe some other examples, or I'll rephrase that so that you better understand. So I want to talk a little bit more about the concept of diffusion, just to, reaffirm some of the ideas. So we know that all molecules in a solution or a gas, we know that they're moving around randomly, right? But that's referred to, we've never referred to it as that, but often it's referred to as something called Brownian motion, right? Atoms are in constant motion. And, this reminds me of kinetic molecular theory from grade 11 chemistry. The more molecules are moving around, the more they're going to collide with each other. And that's going to cause them to spread out, go from an area of high to low concentration. That's essentially what diffusion is. And so that we end up with a sort of consistent concentration of molecules or atoms throughout whatever it is that's, the surrounding area. So in liquids, what happens is that if you increase the temperature, right? Well, remember, temperature is just a measure of the average kinetic energy of the molecules of a substance. So if you increase the temperature, those molecules are going to move faster and therefore collide harder with each other. And that's actually going to increase the rate of diffusion. So I want to show you this cool video that demonstrates that. I would normally do this in class, but since we're viewing this online, hopefully this will do. Let's check it out. Okay, so unless, in case you're unfamiliar with relative temperatures, this beaker here on the left has hot water and the beaker on the right has cold water. Let's see how that affects the rate of diffusion. So pretty powerful. We can already see how on the left in the hot water, diffusion is happening much more readily. You can see the waves of solids trying to diffuse, whereas in the colder water, those molecules are having a much harder time mixing with that water, right? Colliding with each other and then diffusing. Well, in gases, we need to remember that gases are affected by pressure, and so if you increase the pressure, then you cause the molecules to want to squish together, and if they're squishing together, then they're going to collide more often, and that's actually going to cause an increase in the diffusion rate. I'm trying to think of a really good example of that. Maybe think about if you have a balloon that you've untied, and like you've blown air into it, but you haven't tied it quite yet. Well, there's a difference between if you try to pull the top of it, you know how sometimes you pull it and it makes that squeaky noise. If you pull the top of it and you just let it happen on its own versus if you're applying pressure to that balloon, right? That's going to force the air out quite a bit faster. So it's sort of the same thing with gas molecules trying to diffuse across the membrane. The higher the pressure, the more quickly they're going to move through. So the question becomes, well, why do we care about this in biology? Well, we need to care about this because it's important for the diffusion of really important molecules, right? So O2, for instance, we know that O2 should be high in our blood. Well, why is it in high concentration in our blood? Because our heart is constantly reoxygenating with the help of the lungs, reoxygenating our blood and circulating it around, and so that when it ends up at our cell where there is low O2, it's going to want to diffuse there because, you know, molecules always diffuse from high to low concentration. Okay, and remember, why is it low concentration of O2 inside the cell? Well, the cell is constantly using that O2 up, and so because it's using the O2 up, there's going to be a void of it constantly. It's always going to be in need, and that's going to allow for the blood to constantly be supplying the cell with O2. And of course, the reverse would be true for CO2 because CO2 is constantly being produced in the cell. We're going to want to get rid of it, and so the fact that there would be low CO2 concentration in our blood helps the CO2 to move out of the cell. Okay. So facilitated diffusion, let's take a look at that. So it's some sort of diffusion, but the word facilitated to me means that there's some sort of help happening there. It's not happening on its own, it's getting a little bit of help. And so the help in this case is being provided by a protein carrier molecule or a channel protein, and we'll talk about each of those. Those are embedded within that fluid mosaic of the cell membrane. So that just allows certain molecules, particularly charged particles, to move through the membrane. Charged particles have a hard time moving through this hydrophobic interior, right, where it's nonpolar. So if you're a molecule with a charge, you're not going to easily be able to move through that plasma membrane, so you're going to need some help, right? And so think of this channel protein as almost being like a tunnel that these polar molecules or charged particles can move through more easily. And so the channel protein itself will likely have some polar R groups in it that will, you know, help these charged particles to move through and just to travel through to the inside of the cell. Okay, so just remember that these channels, the tunnel, is going to be very specific. We don't want to just let any polar molecule through or any ion through. So they're going to be specific to the ion that they're trying to help through into the cell. And so that's another aspect of the cell membrane being selectively permeable. So sometimes there are issues with this, you know, where there are problems with facilitated diffusion. And it can be, I don't want to go into the details of why that can happen, but to sum it up in sort of just general terms, cystic fibrosis, not sure if you're familiar with it, it's a really debilitating condition where you end up with a lot of mucus in your lungs, right? So you're constantly trying to clear your lungs. It's like breathing through a straw all the time. And that's really caused by a defective chloride ion that won't diffuse across the cell membrane and break up that mucus. It's obviously a lot more complicated than that, but that's an example of the importance of these channel proteins in allowing materials in and out of the cell. So again, remember that facilitated diffusion means that the particles that are being diffused across the membrane are not requiring any energy to help them, but they are getting help in the form of some kind of a transport protein. So these carrier proteins, as opposed to the channel proteins, don't act like a tunnel. To me, they're sort of almost like an elevator. So instead, they move on in through, and it's almost like a gateway of sorts. There's sort of like a stop point. So they go in, they bind to these large protein molecules, and that helps them to get through. So kind of like an elevator. So the protein carrier for glucose will be very, very specific to glucose only, and that will help that large molecule to move through and get into those red blood cells, right? Whereas, other sugar molecules that we don't need as much don't diffuse as much. So the priority becomes glucose, and the carrier protein will want to get that glucose in before it gets any of those other sugars in. Okay, really important for cellular respiration and maintaining energy levels within living organisms. So there's a really cool video that you should watch on facilitated diffusion just to help with some of the visual understanding of what's happening. And so now we're done 2 of the 3 types of passive transport. Remember, passive transport, not requiring energy, but a couple of 3 different mechanisms. The first, just simple diffusion. The next one, facilitated diffusion. And the last I'm going to save for the second video, and it'll be entitled osmosis.